Hi, I've had a few questions on how to approach finding your percent recovery for the two different dies. Now for that, I thought I'd just do a quick little video to show you the approach. Now, I wasn't able to turn off my second monitor for this, so you might notice my left to right is a little bit accelerated. It's because it's stretched double the width. Now, suppose that we had, actually let me start out with black. Suppose we were making a graph of our spectrum. Remember that the thing we had control over, the thing we were actually dialing in on the spectrometer, was our wavelength. And that's going to go onto our x-axis. So whatever we have good control over is the thing we put on x. And remember that we want to label that with a unit. Over on y is the thing that we're going to be measuring. And so for that we measured the absorbance. And as I pointed out in class, absorbance doesn't really have a unit because it was the percent transmittance divided by the percent transmittance, then into some other equation, and whatever unit we had right here, and whatever unit we had right here cross-canceled. So whatever goes into that next calculation to get to absorbance had no unit. But that's really weird for us, so we'll usually write AU for arbitrary units or absorbance units, or you can technically just leave that blank. But we do want to label our axes. Anyway, I just wanted to point that piece out. Now we're going to have some spectrum. Actually, let me do this in purple. Okay, so let's go ahead and sketch the purple dye. Your sketch is going to look something vaguely like this. Well, not sketch. Your graph is going to look something vaguely like that. Now let me also just point out that you would have graphed, I put out on your graph that you had probably 400 nanometers to something like, I'll just put 800 nanometers. Yours may vary. I don't have the manual open right now, so I'll just put it there. So you have these. Now remember that this is our red end of the spectrum. And over here, as you found when you made your tables, this is the violet end of the spectrum. So where are we going to see blue? Like, what is going to look like a blue dye to us? Well, that means the blue light is getting to our eye. So it must be absorbing everything but that. So over here should be where things were absorbed by our blue dye. Now, if we weren't perfect at getting every blue molecule into that vessel, and of course this should be smooth, but we're dealing with my handwriting today, so just pretend that that's smooth and mirrors the shape of what you see above. At whatever wavelength we want to do our measurement for lambda max, I'm sure yours is going to be different than what you see sketched here, as long as you do it at the same wavelength, what you're really saying is, if I definitely didn't lose anything because it was still mixed together for my purple dye, what percentage was the absorbance that I got for my blue sample? So if this happened to be, I don't know, I'll make up a number. This happened to be 1.00 for its absorbance, and this happened to be 0.90 for the absorbance. Then it'd be a 90% recovery, because what I got here is 90% of what my maximum should have been, right? So your numbers will vary for that, of course, right? And then we would do the same thing for the other wavelength max. Let's see if I can do my sketching better. Not too shabby. It's going to converge more like that. Now suppose that for this lambda max, I did the same sort of a thing, and I said, well, look at this, my percent recovery is going to be pretty good. I'll still call my top one 100% recovery. So let's just change the numbers up a little bit here. Suppose that it was 0.287, and then for my red dye, it was lower, 0.2, I don't know, 81. So now to find the percent recovery, we'd say, well, if my maximum number is 287, that's 100% recovery because we didn't separate it at all, right? So there's no difference in what we'd recover. It's already there. For the other one, I would just say, great, let's compare it to that. 81, there we go. And then, of course, times 100 just to get it on the percent scale. And we grab our calculator and type that in and see what happened. I don't have the calculator open, so I'll just leave that to you as an exercise. But that's the kind of thing that you're going to be doing for finding your percent composition. So hopefully that helps, even though my handwriting and my skill of drawing wasn't so great. I'll work on trying to be able to turn off the other computer monitor. I thought about doing that, but unfortunately my mouse is plugged into the outlets on that one, so I couldn't actually draw if I turned off the monitor. All right, well, hope that helps for you.